From space to our homes, how NASA changed everyday life. When most people hear the word NASA, they imagine rockets shaking the Earth, astronauts floating in silence, or distant planets glowing in darkness. Space exploration feels enormous and far away from ordinary life. Yet many of the objects we use every day exist because scientists were trying to solve problems in space. Memory foam mattresses, cordless tools, smartphone cameras, water filters, scratch-resistant glasses, emergency blankets, and even modern medical devices all trace part of their history back to NASA research. These inventions are called spin-off technologies. Products originally developed for space exploration and later released to commercial companies for public use. Since the 1970s, NASA has documented thousands of these technologies. But the deeper story is not simply about clever inventions. It is about how humanity's attempt to survive in the harshest environment imaginable ended up transforming life here on Earth. Why space creates better technology. Space is unforgiving. Astronauts cannot stop at a repair shop, open a window for fresh air, or waste resources carelessly. Every tool aboard a spacecraft must survive extreme heat, violent pressure, radiation, and zero gravity. That pressure created a unique engineering mindset inside NASA: solve the impossible first. NASA did not develop lightweight cordless tools because engineers wanted to make housework easier. They developed them because astronauts on the moon could not drag electrical cords behind them while wearing bulky spacesuits. NASA did not create advanced water recycling systems for convenience. They created them because astronauts had to reuse nearly every drop of water available. And once scientists learned how to solve those impossible problems in space, many ordinary problems on Earth suddenly became easier to solve too. The technology hidden inside everyday life. One of NASA's most famous spin-offs is memory foam. Originally developed in the 1960s to protect astronauts and test pilots from intense launch pressure, the material absorbed shock while evenly distributing body weight. Eventually, commercial companies adapted the technology for mattresses, pillows, sports helmets, hospital beds, and prosthetic devices. Another major NASA contribution sits quietly inside nearly every smartphone on Earth. During interplanetary missions, NASA needed cameras that were smaller, lighter, and more energy efficient than traditional systems. Research connected to those missions helped advance CMOS image sensors, the technology now used in smartphone cameras, medical scanners, and digital photography. Even ordinary eyeglasses carried traces of space research. To protect astronaut helmet visors from scratches and ultraviolet radiation, NASA researchers developed highly durable protective coatings, later adapted for sunglasses, ski goggles, and industrial safety glasses. Meanwhile, the challenge of surviving in a closed spacecraft led to major advances in water purification systems. NASA technologies designed to recycle wastewater in space later inspired commercial filtration systems used in homes, offices, and restaurants around the world. Even the handheld vacuum cleaner has a connection to the space program. During the Apollo missions, NASA partnered with Black & Decker to develop lightweight battery-powered tools for collecting lunar samples. That technology later evolved into cordless household appliances and portable vacuum cleaners. More than convenience. Some NASA spin-offs did more than make life comfortable. They helped save lives. Research connected to infrared astronomy contributed to the development of infrared ear thermometers, allowing doctors to measure temperature quickly and safely. NASA-related materials also transformed firefighting equipment. Before these innovations, firefighters carried heavy, bulky breathing tanks that limited movement inside burning buildings. Using lightweight aluminum and glass fiber composite materials originally developed for rocket motor casings, NASA helped inspire the modern self-contained breathing apparatus SCBA, now used by firefighters around the world. Emergency space blankets, originally designed to reflect heat in space, are now widely used in disaster relief, rescue missions, and emergency medicine. Space technology even supports global rescue operations. Satellite-based distress systems connected to NASA research have helped locate lost hikers, sailors, and disaster victims around the world. Most people never notice the invisible infrastructure orbiting above them. Yet in moments of danger, those technologies can mean the difference between life and death. The cycle of innovation. The relationship between NASA and everyday life is not one way. Sometimes NASA invents entirely new technologies for space missions. Other times, engineers improve existing commercial products so they can survive the brutal conditions of space. Those improved versions later return to public life stronger, safer, and more efficient. The result is a continuous cycle of innovation. A camera designed for distant planets improves smartphone photography. Shock absorption systems developed for astronauts inspire athletic shoes and medical equipment. Water recycling systems created for spacecraft help communities facing drought. Even modern GPS accuracy has been sharpened by NASA technology. While GPS satellites are operated by the U.S. Department of Defense, NASA's Global Differential GPS systems helped improve positioning accuracy to within centimeters. That precision affects everyday life in ways most people never notice. From aircraft navigation to precision farming to ride-share apps, finding passengers on the exact street corner instead of merely somewhere nearby. The stars and the streets constantly shape each other. NASA and the future of Earth. NASA's influence is not limited to inventions from the Apollo era. Today, space research is helping address modern environmental challenges as well. Research into growing food during long-duration space missions contributed to advances in aeroponics and vertical farming, where crops can grow using far less water than traditional agriculture. NASA satellite systems also help farmers monitor soil moisture, crop health, and weather conditions with remarkable precision, reducing waste and pollution. In a world facing climate change, food insecurity, and water shortages, technologies originally imagined for life on Mars may become essential for protecting life on Earth. The unexpected gift of space exploration. Critics sometimes ask whether space exploration is worth its enormous cost. NASA's spin-off technologies provide one powerful answer. The technologies developed for astronauts did not remain locked inside laboratories. They became part of daily human life, improving medicine, safety, communication, transportation, and environmental science. Scientists were trying to help humans survive in space. Instead, they ended up reshaping life on Earth. That may be NASA's quietest achievement. Not merely reaching the stars, but bringing pieces of the stars back home.
It's time to study new words in context. 1. Unforgiving. Definition: very harsh or difficult, without allowing mistakes or weakness. Example: the desert is an unforgiving place with extreme heat and little water. 2. Bulky. Definition: large, heavy, and difficult to carry or move. Example: the firefighter carried a bulky air tank on his back. 3. Prosthetic. Definition: an artificial body part made to replace a missing arm, leg, or other body part. Example: the athlete used a prosthetic leg to run again. 4. Interplanetary. Definition: happening between planets in space. Example: NASA sent an interplanetary spacecraft to study Mars. 5. CMOS. Definition: a small electronic device inside a camera that changes light into digital pictures. Example: modern smartphones use CMOS sensors to take clear photos. 6. Filtration. Definition: the process of cleaning a liquid or gas by removing unwanted materials. Example: water filtration helps make dirty water safe to drink. 7. Infrared. Definition: a type of invisible heat light that can be used to measure temperature. Example: doctors use infrared technology in ear thermometers. 8. Motor casings. Definition: strong outer covers that protect the engine or motor of a machine or rocket. Example: engineers used special metal for the rocket motor casings. 9. Apparatus. Definition: a machine or piece of equipment made for a special purpose. Example: the breathing apparatus helped firefighters work safely in smoke. 10. Brutal. Definition: extremely harsh, severe, or difficult. Example: the explorers survived the brutal cold weather. 11. Rideshare. Definition: a service that uses an app to connect passengers with drivers for transportation. Example: she used a rideshare app to get home after school. 12. Aeroponics. Definition: a way of growing plants in the air using water and nutrients instead of soil. Example: scientists use aeroponics to grow vegetables indoors. 13. Vertical farming. Definition: growing crops in stacked layers inside buildings instead of on regular farms. Example: vertical farming can produce food while using less land and water.
Comprehension questions. 1. What are NASA spin-off technologies? Answer: they are products or technologies first developed for space missions and later used by commercial companies and ordinary people on Earth. 2. Why does NASA create advanced technology? Answer: NASA creates advanced technology because space is extremely dangerous, and astronauts need safe, reliable, and efficient equipment. 3. Why were cordless tools originally developed? Answer: cordless tools were developed because astronauts on the moon could not safely use long electrical cords while wearing spacesuits. 4. What was memory foam first designed for? Answer: memory foam was first designed to protect astronauts and test pilots from strong pressure during launch and landing. 5. How is memory foam used today? Answer: today, memory foam is used in mattresses, pillows, sports helmets, hospital beds, and prosthetic devices. 6. What problem did NASA face with cameras during space missions? Answer: NASA needed cameras that were small, light, and energy efficient for interplanetary missions. 7. What technology inside smartphones was improved through NASA research? Answer: CMOS image sensors used in smartphone cameras were improved through NASA-related research. 8. Why did NASA develop water purification systems? Answer: NASA developed water purification systems because astronauts had to recycle and reuse water in space. 9. How did NASA research improve eyeglasses and sunglasses? Answer: NASA developed scratch-resistant coatings for astronaut helmet visors, and later these coatings were used on glasses and sunglasses. 10. How did NASA technology help firefighters? Answer: NASA-inspired lightweight materials helped create modern breathing equipment that firefighters can carry more easily. 11. What are emergency space blankets used for today? Answer: they are used in rescue missions, disaster relief, and emergency medicine to help keep people warm. 12. What does the article mean by the cycle of innovation? Answer: it means that NASA and everyday society continuously improve each other's technology. 13. How does NASA technology help modern farming? Answer: NASA technology helps farming through aeroponics, vertical farming, and satellite systems that reduce water waste and pollution. 14. How does NASA technology improve GPS accuracy? Answer: NASA's global differential GPS systems help GPS locate positions much more accurately, sometimes within centimeters. 15. What is the main message of the article? Answer: the main message is that technologies created for space exploration have greatly improved everyday life on Earth.